So our fundamental theorem of algebra. As soon as everybody saw the word theorem, then we panicked and thought geometry, and then we panicked some more and thought about proofs. But we're just going to use this theorem to help us solve the problem. So a theorem is just something that's actually been proved to always be true in math. So this theorem tells us that if we know the degree of the function, so whatever the degree is, that's how many zeros we could have. So fundamental theorem of algebra says the most amount of zeros cannot exceed the degree. So that means if I have a degree of 5, I could possibly have 5 zeros, but I couldn't have 6. So I can have 5, I could have 4, I could have 3, I could have anything under 5, including 5, but I can't have more than that. So the most amount of zeros cannot exceed the degree. So that would be, for example, if I looked at y equals x squared plus 1. My degree there is what? 2. Degree is 2, so I could have up to 2 zeros. I could have no zeros, I could have 1 zero, I could have 2 zeros, which we know because we know parabolas, what they look like, right? So I could have possible zeros, possible number of zeros equals 2. But now if I go and I actually graph x squared plus 1, what do I know about x squared plus 1? It's a parabola up 1, right? So it actually looks like this. How many zeros does that actually have? How many real zeros? 0, right? It doesn't ever cross the x-axis, so it doesn't have any real zeros. So number of real zeros, 0. So if I could have 2 zeros, and I really only have 0, I don't have any real zeros, how many imaginary zeros do I have? 2. So we're using some simple subtraction today. We're picking out the degree. The degree tells us how many possible total zeros we have. If I cannot see them on the graph, they must be imaginary. That's why I can't see them. So that means the number of imaginary is whatever I can't see out of the total. So pretty straightforward as long as your counting is on point today. So now I could give you the most complicated way I could ask this question would be for me to say determine the number of possible zeros, specify how many are real and how many are imaginary, and I give you an equation. So then with that equation, you're going to need the graph in order to see how many are real. So if you're not a super graphing genius, you're happy that they've invented Desmos.com, right? You go in and you type in the equation, and they give you a picture, and then you can see where it crosses. Right, cool. So I went in and I typed in 5x to the 4th minus 36x squared minus 81, and I got this beautiful picture. And then, if I look at it, what's my degree there? 4. So how many possible zeros can I have? Exactly. So I could have 4 zeros. how many do I actually have? So how many imaginary do I have? Beautiful. Now, if my 0 had a multiplicity of more than 1, that means it counts more than once. So if I had a graph with a degree of 4, but I had a multiplicity of like 2 at one of my zeros, so if I had a weird graph, which this isn't actually possible, but if right here it bounced instead of going through, and this wasn't here, then I would have 3 real zeros and 1 imaginary. So you have to consider the multiplicity when you're looking at them and counting the number of real zeros. Does that make sense? Okay. So make sure you're looking at the number of the multiplicity when you're counting them. So if we had looked back at that original do now question, that had 4 zeros because 2 of them had a multiplicity of 1 and 1 had a multiplicity of 2, so we really had 4 real zeros on that first one. What if I asked you the same question, but I gave you a graph like that? 3x cubed plus 11x squared plus 5x minus 2. And I said, okay, I made you a picture of the graph because I went to Desmos and I typed it in. I don't even really have to give you too much information on the graph because we're not even asking what the actual values of the zeros are. We just want to know how many are real and how many are imaginary. So when I look at that, how many real zeros do I have? 3 real zeros, right? How many should I have? 3, right? My degree here is 3. So my fundamental theorem of algebra tells me I should have 3 real zeros, and I do. So I have 3 real zeros, which means my imaginary zeros, 0. Yeah. Then I could give you absolutely no information, and I could say, how many possible zeros does an odd function with a degree of 5 have? How many could it have? 5, right? For some reason, this one always trips everybody up when it's on a test, and everyone panics and thinks it's too easy and gives me some kind of crazy answer or like writes this long giant explanation of something crazy. But fundamental theorem of algebra says if we know the degree, that's the most amount of zeros we can have. So all I have to tell you is the degree. You don't need to know anything else about this function. If it has a degree of 5, it could have 5 zeros. So we would say here, possible zeros, five. So pretty straightforward, right? Not too bad. All right. So let's look at your classwork.